All right, what I'm going to be talking about today is, let me just go ahead and bring this up right there, is that we've got, and there we go, all right, right there, so, okay, yeah, I gotta remember this particular one, if I move the computer blanks out on me. Oh, and we don't have it now, right? Oh, it's not there yet, I didn't turn it on. There we go. All right. Now, is the green light on up there? Are we coming on? Up there? I was so worried about getting the camera going here that I forgot to turn on the projector. Right there. Okay. Well, is it coming on? I don't see the light there. Yeah, there it is. Okay. You may have to turn off the front lights up there. So, I'm not going to. Okay, I guess it's readable. Okay, I've got two DC motors right here. And okay, I've got two DC motors, and both these motors are bidirectional. So if I put plus, minus, it'll spin this direction. If I put minus plus, it'll spin the other direction. And those directions are arbitrary. I don't know which ones are which out there. So, and that's the whole basis of running this through the H bridge right there. So I've got a dual H bridge, and I just got it on Tuesday. Remember I showed the H bridge the other day that there. It came in on Tuesday morning, and I played with it yesterday and today, and everything seems to be working fine with it. The way this H bridge works is that it's got two inputs for each motor. Now there's more than two inputs out there, and I'll just go ahead and bring up the desktop out there. And somewhere it's up there. And I thought introduction servos Arduino up there. And maybe it's in here, up there. Nope, I don't see it up there. I know that oh, here it is, there it is, okay. This is the H bridge that we've got here. So we've got two motors right here. This is the control for motor 1 right there, and we've got a direction and an enable for each one of these right there. So the direction is either going to be a 0 or 1, depending on what direction I want the motor to go. The enable is either going to be a 0, or it's going to be a 1, or it's going to be pulse width modulated right there. So that there. So I've got two different motors and two different sets of inputs there. So when we look at our H bridge, and I'm not going to handle it very much, but if we look at our H bridge, what we've got here, this is my plus minus 5 volts. I'm running these motors off of 5 volts. That's simply because I'm too lazy to carry a 12 volt power supply up here. So they're not going to run as fast as they should. These are 12 volt motors, but they'll run less up there. This is my connector right here that goes to my Arduino processor right there. These are our two motor connectors. So if you look at these right here, and I'm not going to pull them up very high, but you can see I plug my motors straight into the H bridge, and you can see where my plus or minus is plugged into the Arduino at the bottom right there. So, matter of fact, I'm going to hold it up in front of the camera later. So, out there. So that's basically these two connectors I'm not using right there. Those two connectors are not being used this time. These are used if I have different voltage motors. Since I'm using the same voltage to both motors, I'm going to be using just that connector. And I'm sourcing the motors from the Arduino board, hence the need for the extra power supply. Because my laptop will not, oh, you know what I bet I did not bring? Yeah, it's all right because I'm not going to reprogram the board. that there. I'll just plug it in. So I'm not going to reprogram it. Whatever program's in here, I'll demonstrate, which is the last one I did. So that there, I didn't bring the USB cable. So I'm not going to go through and reprogram the board multiple times. I'm just going to, whatever software is in there is the last version I was working on earlier today. So we'll just go with that. So when we look at this here, now, this is my connector on the edge of the board. It's 2 layers, 6 pins per layer, right there. And I've got those connected right here and here. So those are the 2 connectors. A is the motor 1 and B is the motor 2. The little symbol there that looks like a bare footprint shows pin 1 on each of those right there. So those are connected. So motor 1 is one connector, motor 2 is the other connector. There's 4 wires per motor connected up. The 2 that I write to are the enable and the direction. We mentioned that. The other 2 are the ground and the VCC. And that's 3.3 volts, and that's coming from the Arduino board as well, right there. So those are my 4 connections between the motor, the 8 connectors between the H bridge and the Arduino. So that's really all the wiring we have to do, right there. So, right there. So I've got the 5 volts across the top, right here. That's coming off the 5 and the ground right there. So that's all coming right off the Arduino there. And then I'll give you the connections for the other 4 are the data lines that are coming off the Arduino. And they're connected on the other side, right there. So I don't have the Arduino picture here, but that's all right. Okay, let me go ahead and pull up the Arduino software. You can go through the Arduino software. As I said, I did not bring the USB cable. So since I didn't bring the USB cable, open recent, open H bridge, right there. Okay. This is the code that I wrote up there. E1 and E2 are my 2 enable pins. So those are the pins that are going to use pulse width modulation. Now, my 2 control pins are control pin 1, and actually this should be direction pin for, this should be direction pin for motor 1, and this is direction pin for motor 2, right there. It doesn't matter if I break the program, I'm not going to download it anyway, so right there. So my setup right there basically is my 2 directions are on pins 8 and 9, and my 2 enable pins are on pins 10 and 11. So those are the 4 pins I'm using to control these motors right there. So they're all output pins right there. So I just define them as all output pins. Now the Arduino's a little weird. I'm going to first start off going in one direction with one motor and one direction with the other motor, right there. So, and I'm turning the enables high, which means that I'm putting a full 5 volts out on those, so they're going to run at maximum speed, right there. Then I'm going to use a function call called analog write. I do not like the term analog write, but it actually sends out a 50% duty cycle PWM signal. Right there. It is not sending out an analog voltage. It's sending out a PWM signal. But whoever wrote the library actually used what I consider a bad name for it back there. But analog write actually means that it's going to send out the PWM equivalent of 150 out of 255. So if you use the analog write function, you're going to give it a number between 0 and 255. 0 is 0 duty cycle, 255 is 100% duty cycle, and 153 is about a 50% duty cycle. Then I'm going to let it run for about a second. Then I'm going to run it at quarter speed, so you're going to see 3 speeds run. Then I'm going to basically turn both motors off for about a fifth of a second. And all that does is stop them from jerking so much. Because the next thing I'm going to do is I'm going to re-enable them as high and switch the directions of the 2 motors. So I'm going to go full speed, half speed, quarter speed, stop, and then full speed the other direction, right there. And then I actually did it a little differently. I went quarter speed, then half speed, and then I shut it back off again, and it just repeats right there. So this is the full program. And again, I use the Arduino simply because it's a much easier way of doing that there. But you can see how easy it is to control the speed that there. And this is using any DC motor right there. My only limitation is this particular H-bridge only gives me about 2 amps right there, which is quite a bit that there. You know, these motors, if I'm running at 2 amps, is a lot right there. So again, what we're going to see when I run this is it's going to go in one direction, full speed, half speed, quarter speed. Then it's going to stop. You won't even notice it stop because it's still going to be coasting that there. And then it's going to go full speed in the other direction. You'll see both motors change directions right there. And then it'll go quarter speed and then half speed right there. So that's essentially what's going to happen. And I am going to have someone come up and help me that there. I'm going to hold this here. And what I'm going to have you do that there is, that's fine. No, I want you to hold this right here. It's the board right there. And I'm going to bring this up here. And here's the key is I'm going to try plugging this in. Right there. Okay. And I'm going to hold the 2 motors here in front of the camera. Okay. Now we're going full speed, half speed. Okay. I don't know where we're at here. That there. There's quarter speed. Then we reverse full speed. Here's half speed, and then full speed. So you can see we're changing both directions right there. Now, it looks like they're both going the same direction, so I probably have got them, you know, they're supposed to be like this right here, so if they're both like this right here, you can see that they're going different directions. That they're, if I hold them like this, they look like they're going the same direction right there. But you can see that I'm clearly changing, controlling the speed and controlling the direction. There. That's the whole purpose of this whole experiment, is to be able to do that. There. And it's all under software control. I can control the speed anywhere from 0 to 255. And I would demonstrate that, but I left my cable upstairs. You know, I think everybody believes me. If I could do this, then you know I can do it pretty much any speed between 0 and 255, and I can change the direction any way I want under microprocessor control. So it's working exactly as it's supposed to be doing that there. So, all right, now if it don't work anymore, I don't care, because we got it working. It worked once, and everyone's seen it work, and we got it on video, right? That there. So that's essentially the whole purpose of what I was wanting to show. That there. Yeah, that there. Yeah, this is the H-bridge right here. I'm going to go ahead and unplug this right here. Right here. Right there. And you can see this is the connection between the motors, and right there like that there. And then this goes between that and the Arduino. The only thing I got the bread for is for my VCC ground, so you can go ahead, that there. So you can see The wiring is not difficult, obviously. The wiring, once I figured out how I wanted to wire it up, it took me probably 20 minutes to wire it. It took me more time to write the code. And the only thing that confused me is, because I have not used the Arduino much, is that I was looking for a PWM command, and there is none. Matter of fact, if you look at the Arduino, oh, that's the servo up there. Nope, I didn't. Oh. This is the Adafruit. This, again, they're using a cheaper motor. This particular one here, breadboard way, yeah, they don't, this one here just shows the wiring. It doesn't tell us anything about the code right there. So this is on pin 12, page 12, maybe. Oh, okay. Again, this particular one right there, and again, motor speed. This one here actually, in one direction. Yeah, I don't have the, I didn't save the, do I have internet in this room here? I never seem to have internet in this room. I try to get it every now and then, and our internet in this room never seems to come up. It says I'm connecting, and it never connects. Yeah. All else fails. Since I mean, we got IUM. What, Android? Well, it doesn't see it right there. Oh, there it is. Oh, okay. Now it's connected. Okay. The only reason I brought this up was that I wanted to bring up analog, right, artery. I think that actually. And I've got internet there. The only thing I wanted to bring up here was I just wanted to show in the data sheet that the analog write command actually does generate a PWM signal. Right there. Even if you don't believe that it does, it doesn't matter, because if it wasn't given PWM, the H-bridge would not work. The H-bridge requires a PWM signal. I can't put an analog signal in and expect the H-bridge to generate an analog voltage to the DC motor. The H-bridge relies on a PWM signal to turn it on and off, because those are just JFETs that turn on and off. So if it's not a PWM signal, it'll either turn it on or not turn it on, depending on the biasing of the JFET. So it appears that I'm not going to get the data sheet that there to say that, but that's all right. But the analog write is the command that sends the PWM signal to it right there.
It's not PWM, it's control the speed.
The PWM controls the speed, yeah. Because what happens, what's happening with the motor is when you give it a PWM signal of 100, 255, you give it 255 or a 1, it's on all the time, so that's full speed. If you give it 75, it's on about a quarter of the time, right there. If you give it 153, it's on about half the time, right there. So what's hhatpening that there is the longer it's on, the more power is being delivered to the motor, the faster it goes. So what the PWM is it's simply pulse width, and you're just giving it a duty cycle right there. And 100% duty cycle, 255 equates to 100% duty cycle. 0 equates to 0% duty cycle. And about 152.5 equates to 50%. And it looks like 152, so it looks like 76 is going to equate to roughly 25% right there. So by changing my value in my code here between, I say high, I could just as easily say 255 there, right there, to 153, that takes it down to 50% duty cycle. I take the 75, that takes it down to about a 25% duty cycle, right there. Then I turn right around and put it back at 100% going in the opposite direction. I just flip the directions. And then I take it to 75%, 75, which is 25% duty cycle roughly, right there. 76 is closer to 25%. And then I give it 155, which is close to 50% again. So it's going to go in full direction, full speed, half speed, quarter speed. And then it goes full speed in reverse, quarter speed, and then half speed in reverse. So that's exactly, and that's what it was doing right there. So, that there. So when we hook this up, we could see that we can control the motor easily right there. So, is there any questions on this that there? I realize this is a short demonstration. There is no analog voltages here. That is the misconception here. We have no analog voltage right there. There. The analog write is actually a lie. It's actually a PWM write. That's why I don't like the term analog write that there, because it's not putting out an analog voltage right there. It's putting out a PWM voltage right there. The Arduino does not have an analog to digital converter or digital to analog converter built into it. It has an analog to digital converter, so we can read analog signals with it. But we're not using the analog inputs at this point. The lab that or the paper that I brought up actually had where is it? Yeah, because this one here is just a DC motor, and this just does just shows how to reverse it. And actually, this one here uses another H bridge, and their H bridge is different, and that only doesn't show the whole thing right there. Right there, I didn't get the whole thing there. Yeah, I don't have it right there. There's another lab. This is the dual H bridge. That there. No. Right there, because this is our dual H bridge. data sheet. And that's just the same data sheet that I had up there. The diligent robot. Right there, the keypad. That didn't give me the full, for whatever reason, that did not. Yeah, this particular one here, actually, if you look at this code here, it's got a speed that's equal to analog read pod in. See, this one here, this particular one here, we've got a input pin right there. Switch pin right there. It's a pot in pot in right here, and pot in, pin pot in, switch pot in. It's not shown here in my setup there. One in output, enable pin, switch. But this is, pot in is on pin 4, and pot in should be defined here. Why? Enable pin, it says is equal to 0, but that can't be, that's not the right pin number. I did not look at doing that there. Factor 4. This uses a button to switch that set motor. Enable pin, reverse, right there. They're pulling the center pin of the. Oh, I guess they are bringing it into analog 0. Okay. I didn't look at that. There is a pin labeled analog 0, so they're bringing that one in right there. Because the Arduino, if you look at the pins here, we've got pins 8 through 11 right here. These are all PWM pins right there. Actually down to 5 actually. These are all pins here. 3, 5, 6, 9, 10, 11. Those are PWM pins. They're not analog output pins. They're only digital high, low, or PWM right there. We've also got 7 pins over here, 6 pins over here that are analog in pins. So we do have, this board does have A to D built into it. It doesn't have D to A. So it does have an analog read function right there. Digital analog read function right there. And that does truly read an analog right there. And I didn't put a pod in here to run this particular code. I looked at it right there. But what this code does is it reads the analog in, it checks the digital read, it checks the switch pin. In other words, it's checked to see whether it's going to be in reverse mode, and it sets the motor speed. And so it does an analog write using the speed, and the speed is bound by reading the analog port and dividing by 12 right there. Or you divide by 4, because that's a 10-bit analog number that it reads, and we have to have a number between 0 and 255, so we divide it by 4, and this uses a push button to say what direction we want it to be in right there. This one has two pins for the reverse right there. Our H bridge only has 1, so this code would not work on our H bridge. We'd have to modify it. Actually, all we would have to do is just take out one of these lines right here. Right there, we just take out one of those lines that there. So our analog right there. So we would call this direction 1 right there. So this code could be easily modified. The only thing is that you would have to add a pot between 0 and that there, and then it goes to analog 0 right there. Is what that is the way that this code works. So I chose not to do that because I didn't have a pot handy that there. I probably could have gone up and begged, borrowed, or stole a pot from the technician, but I just choose just to pick 3 speeds and just show. This one here, you can turn the pot and adjust the speed accordingly right there. So again, it's the same basic concept right there. These motors actually, if you look at them, they have gears in them. Right there. They're a little bit, they're geared down for higher torque. Right there. So.
But still, understand why they want to have many wires.
But there's 2 more wires for sensing to see whether or not, to check the speed, whether or not there's problems. There's 2 wires that are brought to this for feedback to the H-bridge that they're for sensing. We're not using them. We're ignoring those wires. So they're not hooked up. Those wires are not hooked up on this connector right here. So if you go back to the H-bridge, if you look at this H-bridge, those are our 2 directions, but we've also got our sensor feedback wires right there. Those are for Hall effect sensors, so we can make sure the motor's running properly and check the speed that they're, so that because these motors here will set pulses back to the processor to make sure it's going at a certain speed. So if we wanted to ensure this is going at so many RPMs, we can adjust that software if the load slows it down. We're not using that feature. We're just letting it run open loop. But if we wanted to run this with feedback control, that's what those 2 wires are for. But those are the 2 sensor feedback wires, and we're just flat out ignoring them right there. Because those are sent to the motor, and then those are also, we also can feed those back up to the processor, because those are also brought, they're brought here, and then they're also brought in on our motors right there, which I don't show the motors. Yeah, here they are, right here. These are the connector for motor 1, our feedback, our power supply right there. And these are our supply for motor 1 right there. So, but that's what those wires are for right there. So we're just flat out ignoring that there. And I'm just curious whether or not I broke this thing or not. Which one's 12 volts here? I think this is the 12 volt, or 5 volts to the side here. I'm going to fire it up just in case, just to see if it works, still works. Right there. Right there. Right there. And the paint right here. Oh, I can't test it. I unplugged this thing. And as you can tell, I brought this from the States. The power supply. I pulled the brown wire so. So it's still working. Full speed, half speed. Yeah, so it's you see the reason I went in this direction, full speed, then quarter speed, then half speed, is because the difference between full speed and half speed, sometimes it's hard to see. Right there. See, there's half speed. Now it's full speed the other direction. But you can definitely see the speed change. Right there. And again, they appear to be going the same direction as I'm holding them this way. But if this was mounted on a car, then obviously this thing would be spinning around in circles right there. And my wheel is probably about ready to pop off, right? it's getting up there. So, all right. With that said, I'm going to shut down my recording.